Bundling 4 or more non-metallic sheath cables, often referred to as NM cables, for lengths of 24 inches or more does present a safety issue in residential construction. The primary reason is the potential for overheating. When cables are bundled together, the heat generated by each cable is trapped within the group. This reduces the cable's ability to dissipate heat effectively. The result is an increase in temperature within the bundle, which can lead to several problems. The increased temperature can damage the insulation of the cables. Over time, this degradation of insulation can lead to short circuits, ground faults, and ultimately, electrical fires. To mitigate this risk, the National Electrical Code (NEC) provides guidelines for the installation of NM cables, particularly when they are bundled. The NEC aims to ensure that electrical installations are safe and compliant with accepted industry standards. One key aspect of these guidelines is the requirement for a minimum separation between bundled NM cables. According to the NEC, a minimum separation of 12 inches, which is approximately 305 millimeters, is required between bundled NM cables that run for a length of 24 inches, or 610 millimeters, or longer. This separation is intended to allow for adequate ventilation and heat dissipation, preventing the cables from overheating. There are several methods to achieve the required separation. Firstly, one can splice the cables and run them separately. This involves interrupting the continuous run of the cables and creating individual pathways for each cable or smaller groups of cables. This method ensures that each cable has sufficient space to dissipate heat. Secondly, spacers or clips can be used to physically hold the cables apart. These devices maintain the required 12-inch separation along the length of the bundle. Spacers and clips are typically made of non-conductive materials and are designed to securely hold the cables in place. Thirdly, another approach is to install the cables in separate conduits or cable trays. Conduits are enclosed raceways that provide a protective pathway for electrical cables. Cable trays are open support systems that allow for the horizontal or vertical distribution of cables. By using separate conduits or cable trays, each cable or small group of cables has its own dedicated space, minimizing the risk of overheating. The separation between bundled cables must be maintained at regular intervals along the length of the cables. While the NEC does not specify a precise interval, a common recommendation is to provide separation every 3 to 4 feet, which is roughly 0.9 to 1.2 meters. This ensures that the cables remain separated and that heat dissipation is consistent throughout the run. Several additional considerations can affect the separation requirements. Firstly, the number of cables bundled together has a direct impact on the separation needed. The more cables that are bundled, the greater the potential for heat buildup. Consequently, the required separation distance may need to be increased to compensate for the increased heat load. Secondly, the ambient temperature of the surrounding environment also plays a role. In warmer climates or areas with poor ventilation, the cables may be more prone to overheating. In such cases, it may be necessary to provide additional separation or take other measures to improve heat dissipation. Thirdly, the type of insulation on the cables can also influence the separation requirements. Some types of insulation are more resistant to heat than others. Cables with high temperature ratings may be able to withstand higher levels of heat without degrading. However, it is still important to provide adequate separation to prevent overheating and ensure the long-term reliability of the cables. Local building codes and manufacturers' instructions are important. These resources provide specific guidelines and requirements for electrical installations in a particular area or for a specific product. Adhering to these codes and instructions ensures that the installation is safe and compliant with all applicable regulations. The NEC serves as a comprehensive standard for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is an essential resource for electricians, contractors, and other professionals involved in electrical work. Failure to comply with the NEC can result in fines, penalties, and even legal action. More importantly, it can increase the risk of electrical hazards such as fires and shocks. Therefore, it is crucial to follow the NEC guidelines and ensure that all electrical installations are performed in a safe and professional manner. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. The information provided regarding the National Electrical Code and its guidelines are based on generally accepted interpretations and practices. However, specific requirements and interpretations may vary depending on local jurisdictions and the specific edition of the NEC in effect. It is essential to consult the latest edition of the NEC and any applicable local amendments to ensure compliance with all relevant regulations. Furthermore, electrical codes and standards are subject to change, and it is the responsibility of individuals performing electrical work to stay informed of the latest updates and requirements. Failure to comply with applicable codes and standards can have serious consequences, including fines, penalties, and potential safety hazards. When dealing with electrical installations, it is always recommended to err on the side of caution and seek the advice of a qualified professional. A licensed electrician or electrical engineer can assess the specific circumstances of the installation, provide guidance on the appropriate wiring methods and materials, and ensure that the work is performed in accordance with all applicable codes and standards. In addition to the separation requirements for bundled and end cables, there are other important considerations for electrical safety in residential construction. These include proper grounding, overcurrent protection, and the use of appropriate wiring methods and materials. Grounding is a critical safety measure that helps to protect against electrical shock. It provides a low-resistance path for fault currents to flow back to the source, tripping the circuit breaker or fuse and interrupting the flow of electricity. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They automatically interrupt the flow of electricity when the current exceeds a safe level, preventing damage to the wiring and reducing the risk of fire. The selection of appropriate wiring methods and materials is also essential for electrical safety. The NEC specifies the types of wiring methods that are permitted for various applications, taking into account factors such as the voltage, current, and environmental conditions. It is important to use only approved wiring methods and materials that are suitable for the intended use. Regular inspections and maintenance are also crucial for maintaining electrical safety in residential buildings. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems or hazards. Maintenance tasks such as tightening connections, replacing worn or damaged components, and testing ground fault circuit interrupters should be performed on a regular basis to ensure that the electrical system is functioning properly. By following these guidelines and taking appropriate precautions, it is possible to minimize the risk of electrical hazards and ensure the safety of occupants in residential buildings. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents. The heat generated by electrical cables is due to the electrical resistance of the conductors. When current flows through a conductor, some of the electrical energy is converted into heat. The amount of heat generated depends on the current, the resistance of the conductor, and the duration of the current flow. Cables are designed to dissipate heat to prevent overheating. The insulation surrounding the conductors helps to protect against electrical shock and also provides some thermal insulation. However, if the heat generated exceeds the cable's ability to dissipate it, the temperature of the cable will rise. Over time, this can cause the insulation to degrade and potentially lead to a fire. Bundling cables reduces their ability to dissipate heat because it restricts airflow around the cables. The heat generated by each cable is trapped within the bundle, causing the overall temperature of the bundle to rise. This is why it is important to separate bundled cables to allow for adequate ventilation and heat dissipation. The NEC provides specific guidelines for the ampacity of conductors, which is the maximum amount of current that a conductor can safely carry. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. When cables are bundled, their ampacity must be derated to account for the reduced heat dissipation. Derriting is the process of reducing the ampacity of a conductor to ensure that it does not exceed its safe operating temperature. The NEC provides tables that specify the derriting factors for various bundling configurations. These tables take into account the number of cables in a bundle, the spacing between the cables, and the ambient temperature. It is important to consult these tables and apply the appropriate derriting factors to ensure that the cables are not overloaded. In addition to bundling, other factors can affect the ampacity of conductors. These include the presence of thermal insulation, the proximity to heat sources, and the altitude. Thermal insulation can trap heat and reduce the cable's ability to dissipate it. Proximity to heat sources can increase the ambient temperature and reduce the cable's ampacity. Altitude can also affect the cable's ampacity because the air is thinner at high altitudes, which reduces the effectiveness of heat dissipation. The NEC provides guidelines for derriting conductors in these situations as well. When selecting cables for an electrical installation, it is important to consider all of these factors to ensure that the cables are properly sized and aerated. The cables must be able to safely carry the expected current without overheating or exceeding their ampacity. It is also important to use approved wiring methods and materials that are suitable for the intended use. Electrical installation should be performed by qualified electricians who are familiar with the NEC and other applicable codes and standards. This will help to ensure that the installation is safe and compliant with all relevant regulations. In addition to the technical aspects of cable bundling, it is also important to consider the practical aspects of installation. Cables should be neatly and securely installed to prevent damage and ensure long-term reliability. Cables should be supported at regular intervals to prevent sagging or strain. Cables should be protected from physical damage, such as from sharp objects or heavy loads. Cables should be properly identified and labeled to facilitate maintenance and troubleshooting. By following these guidelines, it is possible to create a safe and reliable electrical installation that will provide years of trouble-free service. Electrical safety is an ongoing process that requires constant vigilance and attention to detail. It is important to stay informed of the latest codes and standards and to follow best practices for electrical installation and maintenance. By working together, we can create a safer environment for everyone.